An important kinematics question. If something's accelerating, how far does it travel in a certain amount of time? I can't just take its peak velocity times time because, sometimes it was going slower than that. So how do we handle this? What we know is that distance that something travels is its average velocity multiplied by time. Okay, the average, not just the peak velocity. Like if something's accelerating from 0 to 60 miles per hour, I can't take 60 miles per hour times, you know, um, 1 second and figure out how far the car went. Because sometimes the car was barely moving, it just had a peak speed of 60 miles per hour. Okay, so how do we handle this? Well, we start with what we know, which is that distance is average velocity multiplied by time. Okay, average. Now, suppose you start the week with $0 and you end the week with $100. What's the average money that you had during the week? Turns out that it's exactly $50. Okay, going from 0 to 100 averages out to be 50. So, in other words, the average velocity that something has when it accelerates is one half of the peak velocity that it has. The average is a half of the final velocity. Okay, so it is just velocity times time, but you can't just take the maximum one at the end. You got to take half of the maximum. Now, velocity is acceleration times time. Remember this mnemonic here? The velocity that it reaches would be the acceleration times time. So I can plug that in, and then we'll have our answer. 1 half a times t multiplied by time. In other words, the distance covered by an accelerating object when it starts from rest will be 1 half a times t squared. So you don't just multiply the speed by the time, you actually have to use two factors of time, t times t or t squared, to figure out the distance that's going to be covered. Let's have a quick example of this. The car accelerates, I think it was the stick man, but let's just say it's the car accelerates at a half a meter per second squared. How far does it travel after 3 seconds? Try it yourself, think about it, and try to get an answer. Pause it. I'm going to run ahead and give the answer. Now, I want to know, this is asking how far it travels, not how fast it's going. If I want to know how fast it's going, then I would just take the acceleration times time. That would just be the change in velocity is equal to a times t, and that gives me a half multiplied by the time of 3 seconds, or in other words, 1.5 meters per second. Okay, that's not how far it's gone. That's just how fast it's going after 3 seconds. I want to know the distance that it's traveled. And therefore, I should use the result that I derived here. 1 half at squared gives you the distance. Let's check that. 1 half. Acceleration is a half, 0.5 meters per second squared, multiplied by the time squared. Not just the time, but the square of the time, which is 9 seconds squared. 3 seconds times 3 seconds is 9 seconds squared. And that gives me a distance, which is, it's a half times a half. That's a quarter times 9, which is 2.25 meters. That's how far it's actually gone. Notice I don't take the speed at the end, 1.5, and multiply it by 3. That'd be 4.5 meters. In fact, it only goes half that far. So you can use this equation to get the distance traveled, or if all you remember is the mnemonic, that it's velocity times time to get the distance, that can work too. but you have to take the average velocity. The speed it has at the end, the peak speed that it has is a 1.5. The average velocity is a half of that. So I'd have to take 1.5 meters per second. That's the speed at the end. On average, its speed is half of that much, and multiply it by 3 seconds. That's 1.5 over 2. That's 0.75 multiplied by 3. Guess what? Of course, it's the same amount. That also gives you 2.25 meters. So, that's what I mean by checking it. You can do either way, get the same answer. We trust this, but this works too. It's kind of a shortcut. Either way works. Just remember that so this is during accelerated motion. During accelerated motion, you can't just take velocity times time. You have to take the average velocity times time. Or as a shortcut, use this equation to get the distance traveled.